Hello everyone. We are very happy and excited to announce the new video series on crosstalk. So crosstalk is a term that is being generally used, or it's very famous across the VLSI design engineers, VLSI designers across the industries. So basically this is a term that comes that pinches us towards the end phases of the design cycles. So let me try to explain you and bring up some topics that the crosstalk will hamper. So what happens when we go through a chip design cycle? When we go through a chip design, there are three things that we try to achieve on a chip. So the first of all is the power. So we look for the lowest power consumption on a chip. For example, if you take your mobile phones, you want your battery to be operated for more hours, for basically more than a day. Basically you want your battery to be operating more than 24 hours or something like that. So that is the power. So power is the first thing that we actually focus on. Next we'll look for performance. So for example, if you have if you have a mobile phone and you have 10 applications on it, you still want the same speed, same performance of every application on that particular mobile phone. So basically it should not matter how many applications you open at the same time. Each and every application should be running faster on the same processor on the same time. So that's where the performance comes. And the next is the area. So you will always prefer a smaller handset compared to a bigger one. So a smaller handset basically fits in hand, and on the smaller handset you also want same number of applications that would fit if the handset was bigger in size or double in size. So that's what the expectation is from any of the chips that we design over here. But the term crosstalk, the phenomena of crosstalk, is the one that can hamper all of them. It can destroy power, performance and area in a manner that it's very difficult to recover them. So the emphasis on crosstalk has been very much increased in the recent trends, where we actually go for sub 100 nanometer node. For example, 90 nanometer or 45 nanometer or 20 nanometer in that case. So crosstalk is the term that is basically hampering all of them, and it's destroying all the achieved power performance area on a chip. So that's why it's important to bring up this particular topic and then try to understand what crosstalk is all about and try to identify the fixes without hampering power performance and area, without even deteriorating any of the terms. Okay, so that's where the crosstalk phenomena comes from. So there will be a couple of topics. We have taken topics that are related to industrial problems of crosstalk. So we have taken up those topics and built up this particular series of 41 videos. So let's try to bring up those particular topics that we'll be covering under crosstalk. Okay, so the first thing will be reasoning out the concepts behind the inception of crosstalk. So basically, where does this crosstalk actually starts coming from? So for example, one of the reasons that we can discuss right away is that if you have multiple number of applications, if you have thousands and thousands of applications being bundled on a single chip, in that case you have too many transistors just switching at the same time, and as a result of that there are too many interferences, and that is what is resulting into your crosstalk. This is one of the reason that we identified. There are a couple of other reasons that we will be covering under this particular topic for reasons of crosstalk. Next, what we'll be doing is, so crosstalk has to be quantified based on some thresholds, and these thresholds are modeled in terms of noise margins. So this is what we'll be doing. We'll be taking the voltage levels across what we have across the existing voltage levels, and try to define some thresholds that will identify the crosstalk. So some voltage level, some signal crosses a certain threshold, that will result in noise. Some signals, if they don't cross the threshold, it will still be safe to play with that. So those all things will be studying over here. It will be called as DC noise margin. Okay, then we'll be taking a real-time industrial crosstalk glitch example where we'll be looking into how the crosstalk actually evolves. So on a period of circuit, on a period of the circuit path, if you see, there are ways that we can identify the nearby nets that is actually impacting your victim. So those real-time examples will be covered under crosstalk glitch example. Okay, next we'll be looking into factors that affect the glitch height, so that we now have a hold of the factors, and we can actually tune those factors to reduce the glitch height as small as possible. So we'll be looking into the factors that will affect the glitch height. We'll be looking into AC noise margin. So sometime classifying the noise based only on this particular noise margin, that is DC noise margin, it's not fair enough. Things becomes more pessimistic. So we have to come up with some more accurate approach for determining noise, and AC noise margin is one of them. It basically very accurately determines that which are the actual potentially safe and unsafe noise, and try to fix only those rather than fixing all of them. So it does a more of accurate analysis. So this particular thing, this particular noise margin that we'll be introducing over here, that is more of a flat noise margin, a flat threshold based on only noise height, and this will be basically based on noise width and noise height. So we'll be covering the AC noise margin concepts as well. Okay, next we'll be looking into timing window concept. So whenever there are multiple aggressors impacting a single victim, the timing window approach comes at that point of time. So basically looking into a phenomena where all the aggressors affecting a victim, that's very unlikely. So we need to pick up only those particular aggressors that will be affecting a victim at a certain period of time. So that's where the concept of timing window comes upon, and we'll be looking into this particular concept as we move ahead. Next, we'll be looking into impact of crosstalk on setup and hold timing. So the crosstalk by itself also creates two kinds of problems. One is the noise, and the second one is the delta delay. So there's something called as delay. It basically impacts the delay of a cell. So over here we'll be looking into how it impacts the delay of the cell, and how the setup and how it actually impacts the setup and hold timing. So those things we'll be covering under this particular topic. Next, we'll be looking into techniques to reduce crosstalk. So now that since we have learned all the topics which are related to crosstalk, we need to identify ways or techniques to fix the crosstalk, or to at least reduce the crosstalk and bring it below the noise margin, or bring it within the noise margin range, the AC or the DC noise margin range. So we'll be trying to cover those techniques over here. And finally, we will be looking into something called as power supply noise. So we have been encountering various power mesh structure when we enter into a chip design cycle, and there is a whole sort of concepts behind it, that why we actually went for for a power mesh, and the reason is basically the power supply noise, the ground bounce or the voltage drop that we see over the power supply. So we thought this was the best place to introduce it, because again the voltage droop or ground bounce, those are a part of noise. So we thought of bringing that particular thing over here, and hence and that's the reason that power mesh has been in place for some time from now. So power mesh structure and power supply noise, we will be covering under this particular topic. So now what we'll do is, since I've already covered what all topics we'll be looking into in under this particular set of videos, from the next video onwards we'll be looking into the reasons and some basic definitions for crosstalk noise. So this particular videos we'll be introducing some terminologies that are related to crosstalk, and that will help us to understand crosstalk even in a better way. So let's try to introduce the definitions and the reasons for crosstalk noise in the next video. Thank you.